Yeah, I think you can start.
Now I share my presentation. You can see and hear me.
Yes.
First of all, I would like to say thank you, organizer, for opportunity. Give a talk on this conference. Because of my talk, not very related with semi-groups, maybe, and first of all, consider mathematical model, let omic domain from Rn with smooth boundary, and in the cylinder we consider modified Boussinesq equation or IMBq equation with Dirichlet boundary condition and Cauchy conditions. Where lambda and alpha arbitrary parameters. Equation 1 has many applications in various fields. It may be propagation of long waves in shallow water, taking account capillarity effect and thermodynamic properties of monatomic and diatomic chains, and description propagated strain wave in an elastic rod. In all papers listed above, essential condition is the continuous invertibility of operator at highest derivative, lambda minus delta. However, this operator can be degenerate. Questions that are not solved with respect to highest time derivative according Walk 6 are usually called Sobolev type equations. Using the theory of p-bounded operators developed Professor Sviduk and his students in the suitable functional spaces, mathematical model 1-3 can be reduced to initial problem for an abstract semilinear second order Sobolev type equation 5. Here and below, u dot and u2 dot are the first and second derivatives of function u with respect to t. In my previous work, using the test space method and theory p-bounded operators, I consider the unique local solution. Some words about it. Let X and Y be Banach spaces and operator F be linear and continuously. And operator M is linear and with dense domain. The set rho L of operator M is called the relevant set of operator M, and sigma L of M is called L spectrum. If operator M L sigma bounded, if next condition holds, let the operator M be L sigma bounded, then operators P and Q are projectors in space X and Y respectively. Operator R and R is called right and left L resolvent, where on the L resolvent edge operator L on the right and the left respectively. Projectors P and Q split acting of operators and space X and X and Y. And equation 5 can be reduced to equivalent system of equation. And the set Gothic P is space of equation 5. Thus, the existence of a unique local solution was proved. However, these results don't answer the question how we can construct a solution for this problem. Because let's solve problem and solve the problem 5 and 4 using Galerkin method and obtain algorithm to getting a solution. To do this, we construct several function spaces. H be a real separable Hilbert space and define dual pairs of reflexive Banach spaces, Gothic A and L pair, with respect to duality such that chain of dense and continuous embedding holds. In the given spaces, we define operator Lm and M, satisfying next three conditions: C1, C2, and C3. Due to condition C3, operator N satisfies the equality In addition, we define space of distribution or space of function with values in Banach spaces, and construct conjugate spaces according to the Janford-Pettis theorem. Now I represent some main steps of proof. First of all, of this theorem. First of all, the solution of problem will be sought in form of the Galerkin approximation, where pk eigenfunction of the Dirichlet problem for operator L. We find the coefficient AKM of T from the system of algebraic differential equations. Seven and 8. By theorem about existence and unique solution of this algebraic differential system, there exists a unique local solution UM for T from segment non-TM. The theorem based on the Peano theorem and system of second order reduced to first order and using classical methods. Then we should get priori estimate about approximate solutions. Multiply equation 7 by function AKM with dot and sum over k from 1 to n. Introduce in the space column L with Gothic A, the norm by virtue of the principle current. This norm is equivalent to the norm induced from the space Gothic A, and equation 9 takes the form. After that, we integrate on the segment no Tm, where T less or equal to M, and using Gromov inequality and inequality which goes from embedding, we get inequality 12. The constant C doesn't depend on Tm, And therefore, we may OTM is equal to 1t. And from our estimate 12, we can choose star weakly converged subsequences UML and U.ML from sequences UM and U.M respectively. By the next step, we can show that our nonlinear term M of UM from this we can say that it converges some element, but using recursive properties of operator N and condition C3 isn't difficult to show that N of UM converges to N of U. And now we can pass term by term to the limit inequality 9 tending ML to infinity. Taking into account density of system functions pk in the space erotic A, we obtain equation 16 for every element of erotic A. And similarly, we can pass to the limit in initial condition using that fact if function belongs to L space L2 and its derivative belongs to L2, this function belongs to space of continuously function. And finally, the function u from x and t satisfies the equation and the initial conditions. Now, return to mathematical model 1.3 and reduce to the problem 4 and 5. Introduce Hilbert space H is equal to the subgroup space with compact support with inner product which given by formula here, and we set Gothic space Gothic A is equal to L2. This chain of dense of continuous embedded codes and define operator A by a formula. The condition C1 would be true for O lambda, for O lambda more or equal to lambda 1, where lambda 1 first eigenvalues of the Dirichlet problem for operator L, for operator delta, and the condition C2 will be satisfied if we define operator M by formula and define operator N by next formula. Then check condition C3 and next theorem, there is a place. Thank you for your attention.
Okay, thank you, Evgeniy, for the talk. That was good present. Any question? So there is no question? Okay, that's great. Well, as the chairman of this room, let me say thank you, all of you, especially we had 3 speakers here, and we're gonna have a break for lunchtime until 1 p.m. and we're gonna get back and continue. Thank you all. Bye-bye.
Thank you.
Recording stopped.